Hey YouTube, what's up? Dr. T here, and welcome to the Altcoin Express and my hometown of St. Petersburg, Florida. So in this section we will be covering the Python coding of SensorWorld using Tkinter graphics. Welcome to SensorWorld, Python coding using Tkinter graphics. SensorWorld is a springboard off of a project in CS 188, an introduction to artificial intelligence from Berkeley. So this is GridWorld, as we'll find in lecture 10, and this is about reinforcement learning, and in particular Q-learning. So here we have my GridWorld, and running it off for a few cycles. The agent just wanders around randomly and hits the pit or hits the goal, picks up a reward, and recursively moves that reward back through the grid via the use of the Bellman equation. And for those who are not aware, this is generally the Bellman equation. It updates the reward in any state via the equation that the reward in that state is added to by a scalar alpha times the reward in the next state plus another scalar times the reward of the maximum discount reward, as it's so called, in the next series of states minus the original reward, and that is the Bellman equation for updating. In SensorWorld, we're moving up from GridWorld to the DeepMind publication and the introduction of deep reinforcement learning, or deep Q learning, whichever way you want to look at it. And in this presentation, they state, we present the first deep learning model to successfully learn control policies directly from high-dimensional sensory input using reinforcement learning. The model is a convolutional neural net trained with a variant of Q-learning whose input is raw pixels and whose output is a value function estimating future rewards. That's what this is based on and what's going to follow along with. So here we have my SensorWorld, which was evolved in its design. It has, like GridWorld, two routes to the goal, but they have been separated as a short route and a longer route, and I just evolved putting these other pits in as well. And the purpose now also, this was also taken from the introduction to electrical engineering and computer science class at MIT, which showed an agent that had sensors, and this is an agent, and these little boxes are its sensors, and it'll put out sensors, detect the walls, and it will then allow the walls to be presented. And in the beginning, the agent will see absolutely nothing. It'll appear on the grid, and then as it uses its sensors, it will detect stuff, and that stuff will then be put onto the grid. And in this series, I will go through the coding and explain what I've done. Maybe not the best coding, it's my coding, as how this evolves. And the project will be getting the agent to move randomly around to display all of the state space, and then it will have another series of movements around where it will start to use its neural network and produce the deep reinforcement learning algorithm till it reaches its goal of filling in all of the directions to their optimum value. So in this post, we'll show how you put a window onto the desktop of your coding area, place it where you want it, put a canvas inside the window, set the size, and place a title on it. Our imports will be from Tkinter, import everything. We'll import NumPy because we're going to use NumPy arrays, and time because we're going to use time. So this is object-oriented programming in Python, and our class will be called SensorWorld, and we'll put all our definitions into the init function, and we just data equals SensorWorld for calling the whole of the class to operate. So to draw a window, we apply the init function and we set self-root to tk, and the window self-root geometry, which gives us the size of the window, width and height. We have to call the routine self-root main loop and then call the class function, and then we can run that, and we have a window pop up at that random position that it does. It'll just put it randomly somewhere. Now if we want to specify specifically where we want it, we put add-ons to these x and y coordinates. So let's do 100 by 200 by 100 so we can displace it down. So we'll do plus 100, which should be the x direction, and plus, say, 200 for the y direction, and it should move it over and down. Hopefully we've got that right. And our window moves over and down. We don't see it go very far. Let's take it a bit further. Let's take it in the middle of the screen. Down a bit further. So now we've moved our window over and down. So now if we do self-root title and give it a title, we will be able to put a title on our world, on our window. So there's our title, and we can censor that just by putting dot center and put a displacement in, put 50 in, and that will center our title on the screen. It'll move it along the screen anyway. Move it a little bit further to, I don't know what the center of this little dot is, but we'll move it a bit further. And we've got further along. It's not quite centered properly. So I guess it's somewhere in between. So put it somewhere in between. Depending how big your world is, you have to specify. So, well, we've got a window and with a title, and that title is centered. Now for doing graphics, we need a graphics canvas, and we will now assign self-frame, which is the handle for putting graphics in this case canvas, and we'll put the define the color of the screen, and we'll put the width slightly smaller than the size of that world. We have to do self-pack to get the canvas to be presented on the screen, and when we run that, we have our screen. We've got a window centered where we want it, with a name, with a canvas in, where we can start putting things on the canvas. So next time around we'll go on to the code itself and further aspects of that.